guys, and welcome to this one. Yesterday we looked at the brute force implementation of Fibonacci and how it never stops running and all that good stuff. Now we are here Fibonacci of optimization of the Fibonacci. There is a repetition here every time that someone calls Fibonacci minus one and Fibonacci minus two, it's most likely have been called before. So basically, we see that there are stuff that we have already created before that we are creating again every time we call Fibonacci minus one. So what are we saying? We're saying that when we have Fibonacci of 5, or the index of 5 in a sense, right? And we have Fibonacci, and we have Fibonacci index of 5, and we say 4, Fibonacci of index of 4, and Fibonacci of index of what? Of 3, right? Now, if we go to okay, let us handle Fibonacci of index of 4 first, right? Fibonacci of index of 4 in its own self, we'll call Fibonacci of index of 3 and Fibonacci of index of 2. Now, remember, we have an index of Fibonacci of index of 3 that we are going to solve for when we go back to 5, right? And now 4 also requires that same solution. So it's as if we are just going down the loop of resolving what we've already solved before, rather than solving it once, having it in memory, and then basically making use of it recursively to to remember the value and then make use of it again, right? Saving ourselves loads and loads of time. Basically, one straight line or maybe a linear line will be the solution, because we are going to be solving everything just once and then using it anytime it appears. And that's what we go ahead to do. See, let's take 7 for instance. 6 plus this, okay, that's what I explained. 5 plus 4, 6 plus this thing is 5, 7 is 6 plus fib of 6 and 6 fib of 5, and then we have 6 being fib of 4 and fib of this thing big. I don't know what this is doing here. Then fib of 4 plus fib of 3. So we see that we call fib 5 twice on the first level and second level, and also fib 4 as well. So basically that's what we're trying to talk about. There's no need for that uh, continuous call. So what do? We say optimized all this thing. We take in a number and a memo, which is like which is, it's not like, it is basically a dictionary. And what does it do? And what does it do? Basically, what it does is it goes ahead to say, so it says if the number is in the memory, return memory at that number, right? And then if number is 0, just our base cases, certain thing I define that. Okay, uh, right? So let's see. And recursive case. If I type one more thing wrong, I will explain to my. Okay, let's see. So we say result equals to optimize Fibonacci number minus 1 plus Fibonacci optimized number minus 2. Basically, and then we see memory of okay. So after we get a result, we put it into the memory, and then we return result. Basically, you see that what we are trying to do here is that when we call optimize this thing, optimize Fibonacci, the first line we catch is a line that holds the memory, and this memory holds every Fibonacci that has been called ever. So let's say we call 5 sometime in memory, right? Before, maybe let's say we call 7, just like the instance we gave in line 18 up, right? And we have 6 here and we have 5, right? If we call 5 here and 5 has been solved and we put the value in memory, when we come here now over here at 6 and we've solved and 6 has been resolved because of 5 and 4. Now when we come to this fib in 5 here over here, what we get is simply a 5 that from memory. So when we go into it to go and get it out, what we are going to see is that we are going to first at this line 7 down. Immediately we are going to return 5, and then we don't need to go through this whole process again. We just go back up and then return the value, which is what we are looking for, and basically go ahead to return the result. So we see here that every stuff we solve, we append anyone that gets through this guy over here. He gets to solve it. He gets to solve itself and then pass the value into result, and that's exactly what we need for our solution. And basically they print this is the optimized fib, so we get the result. So that 100 that couldn't run before, that ran endlessly, now begins to run, and okay, runs at even a time of 0.09 seconds. Understanding, I call big O, the big O of the non-optimized. This will be, okay, 2 raised to power n. Okay, 2 raised to power n, not n raised to power 2. So I think I got that wrong, right? We have 2 from each function call. Yeah. So every time we call a function, it's going to do an O of n squared, right? Because it's going to create branches up until the bottom of it. So yeah. That's more like it. Yeah. So as we have 2 from each function call, and this will create n raised to power 2 amount of call nodes if you check it out. Instance 3 inputs. Okay. So we see the left call. I don't think this is the greatest visual representation that you probably help you understand. But basically, what he's trying to say is that three. If you still look at this line, it says that the 8th function calls 2 raised to power 3, and it gives us 8 nodes, right? So if every time I call 3 it gives me an 8th node, you see that it's going to be 2 raised to power 3, right? To solve just for 3. And we see the justification for the big O of n of this. I think what I wanted to write here would then necessarily be big O of uh, big O that is equals to what? O of 2n. Sorry, 2n. So yeah, for the that's for the this thing. That's for this thing, but for the optimize, that's for the uh okay, sorry, that's just brute force. So basically that's it. And then for optimize, have to only we have to only my only has existed twice. I don't know who took me to this type in school, but it is what it is. So only left side of all nodes and store its value for all the right nodes to rely on. Then we have linearized, this process, and hence we are golden, big O of n. So that's exactly what I said earlier, right? It's going to be big O of n because every solution is only solved once, and after being solved once, memoization, and we are cool and we are golden. So basically that's it for this guy. See you on the next one. Alfred as in choose by. If you have any questions, because I know my graphics is not the greatest representation of stuff, so it's obviously for someone that's already like in flow with like how Python works and stuff. So if you have any questions and you need clarification and stuff, please buzz me in the comment sections. Drop your thoughts. Drop your maybe even suggestions on how I can do better and how I can improve the graphics, or maybe the visualization. So maybe you join me on the journey, right? Yeah. So with that said, muchas gracias. Auf Wiedersehen. Choose. See you on the next one.